In this video, learn about factorizing quadratic expressions. To help us with this, we'll just recap a bit. So when we did the expansion of two brackets, expanding two brackets, we did this. We multiplied x by x to get x squared, x by 4 to get 4x, 3 by x to give us 3x, and 3 by 4 to give us 12. And then we collected the like terms and we had x squared plus 7x plus 12. So if we just stop for a minute and have a look at the patterns, what do we have? We've got x squared here, which is naturally the multiplication of two x's. So if I am to reverse this process, starting from this, looking at x squared, I'd put x and x. And then, where did the 7x come from? 3 and 4 makes 7. So here we're looking to put two numbers, which when we add, they give us 7. So that could be 6 and 1, that could be 5 and 2, that could be 4 and 3, 3 and 4, so switching the order and so on. So that's so far. When you also look at the 12, what's the relationship between these two numbers? What do you do to them to get 12? We multiply them. So basically, to fill these two gaps with numbers, we're looking for two numbers which when we add, they give us 7, and when we multiply, they give us 12. So what numbers do we multiply to give us 12? It could be 2 and 6, it could be 3 and 4, and there we have 3 and 4. So to double check, you always go x times x gives us x squared, x times 4 is 4x, 3 times x is 3x, and 3 times 4 is 12. So you just reverse the process. Now we'll have a look at a few more examples. So we've now got x squared plus 6x plus 8, and we're going to open up two sets of brackets. So we've got x squared there, which means x and x. And we've got 6x. So these two numbers that are missing, when we add them up, they will make 6. So they could be 5 and 1. They could be 4 and 2. They could be 3 and 3. But they also need to multiply and give us 8. So which numbers multiply to give us 8? 8 times 1, that is 2 times 4, and there we have them too. So we'll put plus 2 and plus 4. Let's try it out. Does it work? So we'll do x times x, which is x squared, x times 4, which is 4x, 2 times x, which is 2x, and 2 times 4, which is 8. So that's x squared plus 6x plus 8. So we've done it correctly. Moving on to the next one, we've got x squared plus x minus 20. So opening up the brackets, we've got x and x because of the x squared here. Now we've got plus x, which is actually 1. So this is just 1x. So that means that the numbers add up to 1. Now that could be negative numbers as well. So a range of pairs would give us 1. And we can see here that negative numbers are involved. So we'll start with this one instead now. So what numbers do multiply to give us negative 20? It could be negative 2 times 10, or negative 10 times 2. It could be negative 1 times 20, or negative 20 times 1. It could be negative 5 times 4. Which ones of these will actually add up to give us 1? This doesn't. Either way, even if we do negative 10 add 2. And this one doesn't either, even if we do negative 20 add 1. Looking at this one, is negative 5 add 4, that will give us negative 1. But if we do it 5 and negative 4, the answer would be 1. So this is the pair that we're after. So positive 5 and negative 4. Let's try it out. So x times x is x squared. X times negative 4 gives us negative 4x. 5 times x is 5x. And 5 times negative 4 gives us negative 20. So collecting the like terms here, we get positive 1x, or just positive x. And that matches what we have. Looking at this other example, we've got x squared, take away 14x plus 48. So opening up the brackets, we put the x's first, and then we've got two numbers that add up to negative 14 and multiply to give us 48. So let's start with this. What two numbers multiply to give us 48? That could be 48 times 1. That could be 2 times 24. That could be 6 times 8, or 8 times 6. So I think we've got what we need. To get 48, we can multiply two positive numbers, or we could multiply two negative numbers. These two, when we add them together, that would give us negative 14, which is what we have here. So these are the two numbers we're after. So x minus 6 and x minus 8. Let's reverse the process. So x times x is x squared. X times negative 8 gives us minus 8x. Negative 6 times x gives us negative 6x. And negative 6 times negative 8 gives us 48. Collecting the like terms, we'll get here negative 14x. And that's what we have here as well. Let's have a look at a few more examples. So we've got n squared, take away 5n, add 4. So we're going to open up the two sets of brackets. I'm going to put n inside. So not x, not y, just n, because we've got n squared. And n times n gives us n squared. Now we're looking for two numbers which when we multiply they're going to give us 4. And when we add them, they're going to give us negative 5. So as they're going to add up to a negative number, that suggests that they're both negative, because when you multiply them, they give us a positive as well. So which numbers do we multiply to give us 4? Could be negative 4 times negative 1, could be negative 2 times -2. Looking at these two, -4 add -1 gives us -5. So that's the pair of numbers we are after. Reversing the process now to see if we've done this correctly. So n times n gives us n squared, n times -1 gives us -1n or just -n. -4 times n gives us -4n, and -4 times -1 is 4. So collecting the like terms here, we get -5n, and that matches what we had. Looking at the next example, we've got 8 add 9x add x squared. Now we've got these in this order, and if that confuses you, just change it to how we normally see. So x squared plus 9x plus 8. It means the same thing because we haven't changed the operations. Now let's open up the brackets. We get x in both of them. Now we're looking for two numbers which when we multiply, they're going to give us 8, and when we add them, they're going to give us 9. So 8 times 1 makes 8, and 4 times 2 makes 8, but 8 times 1 is the pair we after, because 8 add 1 gives us 9. Let's reverse the process. So x times x gives us x squared, x times 1 gives us x, 8 times x is 8x, and 8 times 1 is 8. Collecting the like terms, we get 9x here, and that matches what we have. Now we've got x squared minus 16. So this looks slightly different. We haven't got that multiple of x. That term is missing in the middle. So what does that mean? Well, let's have a look. And let's start how we normally do. So we've got the x squared. So we put the two x's in the brackets. Now we've got only this last term, which is normally what we use to multiply the number. It's the product of the two numbers that we multiply. So -16. What do we need to multiply to give us -16? It could be -16 times 1, or -1 times 16. It could be -4 times 4. And that is the pair of numbers we're going to use, because when you add -4 and 4, it gives us 0. So there are 0 lots of x. That's why the multiple of x is missing here. That middle term is missing. So I'm going to put -4 and +4, and let's reverse the process. X times x gives us x squared. X times 4 gives us 4x. -4 times x gives us -4x. And -4 times 4 gives us -16. Collecting the like terms, +4x, take away 4x, leaves us with 0. So these cancel each other out. That's why we've got that missing here. So x squared minus 16 is the answer to this one, and matches what we had. What we call this special case is the difference of squares. It only works with the square numbers, as you can see, because we've got to import here the same number, one negative and the other positive, to cancel each other out. So numbers that you could put here are 1, so -1 and 1, -2 and 2, -3 and 3, -4 and +4, -5 and +5, and so on. And that final term is going to be a square number, like 1, 4, 9, 16, 25, 36, 49, and so on. And also, the signs you're going to have in there, they're going to need to be one positive and one negative in order for them to cancel each other out. So always this term is going to have a negative sign in front. So negative 16, negative 25, negative 9, negative 4, negative 1, negative 81. So x squared take away 81, which is the same as saying x take away 9 all squared, which is the same as saying x take away 9 multiplied by x plus 9.